How dare I? They're like, she's talking in there. We know it. We can't hear. It is one of the most loved platforms right now, and people are installing it everywhere and with everything. DB Engines is something that Redgate owns, my company, and we're seeing this. Now, it's really fascinating because I have been using DB Engines since years and years before I worked for Redgate. And so I have screenshots of these rankings back from 2012, 2014, 2016, and watching this. And if you know the algorithm behind this, you know that this is a little askew. It's not, popularity or how many installations or anything. It's a pretty complex algorithm behind it. But we watched Postgres come up pretty quick. Same thing with Snowflake, MongoDB. Oracle and MySQL and Microsoft SQL Server, you started seeing those numbers dissipate, where they started out at like 1,600 each. They were right neck and neck and started going down. So you were seeing those numbers change. But it was really fascinating as all of a sudden in the last 2 years, Postgres really moved up, where the numbers were very different, where these top three stayed very, very high and the other ones were very low in those hundreds. All of a sudden, Postgres came out of nowhere and really pushed forward. And we're seeing the impact that it has in development. Right now, if you're looking at the values on this and the investment that's being made, especially like Enterprise DB, Enterprise DB went and hired a number of really deep Oracle experts. One that I talk to all the time, like Jan Karamans and stuff. And they said, we need to find ways to kind of bring this open source product into a realm that it can be used by anyone and actually build it out in an open source community the way that Linux has done it, so that we can actually invest in something that is going to be worthwhile. And we're seeing this from a number of different corporations, a number of different companies. It's also a favorite of cloud vendors. As I was saying, we've got AWS. They've got their own version, their Amazon RDS, Azure Database for PostgreSQL. Now, I will tell you, I was at Microsoft when this was not getting a lot of love. I had seen a number of my teammates go through this and try to PM this, and everybody was like, Postgres. Oh, no, we've got SQL Server. We're going to migrate it onto SQL Server. I was the Oracle person for Microsoft, so I felt that same kind of unlove. They were like going, oh no, you're those other database platforms. We don't like you. The folks that are running Postgres today over at Azure have a full team now working on the migration assistant, on the accelerator, that they did not have just a couple years ago. So that really empowers me and makes me feel like they're going somewhere. Google Cloud SQL, they've been in it to win it from the very beginning. When I see, there's a couple of my ex-coworkers, again, they're deep Oracle experts, ended up going over there and doing the Postgres and becoming the PMs for it. They have invested deeply into this, and you're seeing a product that literally, with Alloy DB Omni, I will tell you that changes I would recommend to make it more like the pure Postgres, like I think at this time 16 was out. They would make the changes that day. They would be in production the day after. I mean, they were moving so fast, it wasn't even funny, but they were investing fully into it. And then you have compatible databases versus pure Postgres, they're going to have the compatibility with Postgres, but they're going to have their own ways of doing things, no matter if we start talking about high availability, redundancy built into the system, scalability, all of those different areas which are extremely important. I am glad that Microsoft Fabric has learned that relational systems do have a place in their product, that if transactions aren't going in, analytics is not coming out. Somebody finally figured that out. So seeing Postgres in there, as well as SQL Server 2025, made my day. I was literally out there on LinkedIn going, wait for it, we're back. We knew it. We knew it was happening. Yugabyte, heavy Oracle investment here. Bryn Llewellyn, one of the fathers of PL SQL, ended up building most of the product that you're seeing back in the back end product there. Fritz Hoagland, things like that. These are people that really understand how to make it more compatible and compete with some of these enterprise level databases. And we already talked about some of these other ones that you see, like Alloy DB Omni. And of course, Alloy DB, this is your kind of your PaaS solution that's embedded into Google, versus Alloy DB Omni that can be decoupled from Google, installed anywhere. So you could install it on your laptop, on server, on AWS, or anywhere else, and still get Google support for it. So if you had an enterprise level product that you needed support for and wanted to use Postgres, you could do that and then still have that Google support, that paid support behind it. And then these additional ones here, Scale Grid, Elephant SQL, some of these others, Superbase is coming up out of nowhere. I don't know if anybody else is watching them, but they are being used more and more across the board. They're having more released features that people are finding very, very productive into their system. And I am amazed by them. They were up at the Seattle Postgres group. We went and did a hands-on lab, kind of a hackathon of trying to build something out after I'd gone up and done a presentation there. I'd done one on, it was actually AlloyDB Omni and doing benchmarking on it. And so they decided to build out their own benchmark while we were there. Just everybody go in there and do a benchmark on the system. I thought that was really cool that they're that invested into the community. And I think it's starting to show in their product offerings too, is that they've got that dedication from the community to use their products. Nile is a new one, and I shouldn't say new because Gwen Shapira, a good friend of mine, has she's invested her time there again. Another old Oracle person, sorry, we're everywhere. But this is a SaaS offering with Postgres serverless behind it that allows companies that are multi-tenant that need to like deploy databases isolated for like data governance and that they can just deploy them as fast as they want. I think you're going to see Nile come up pretty fast and be used by a lot of different companies. But we're seeing this everywhere. And if you're looking for kind of, just a comparability of what they have and notes on them, I went and put this into the slide so you can kind of look at it. Again, some of my favorites right now, Superbase, Yugabyte, I love, AlloyDB are some of my favorites, but everyone's going to have different flavors that are going to fit their needs. And that's what's the coolest thing I think about it, is that there's so many different flavors that are out there. And depending on what your project is, what you want to try to, enable, you're capable of doing that. So why is this happening? It's free. I think we already said something about $47,500 per core for licensing on Oracle. SQL Server isn't that much less, even with discounts and everything else. If you could reallocate that money that you would put towards your database platform, towards your cloud investment, or towards your AI project, that's kind of nice. I mean, how are you going to spend your money? If we are doing any kind of, like, I do demos for my products, and I want to do it on Oracle, I have to do it on the 23 AI free version of Oracle. I'm looking for a free version to do my demo. That's challenging for me as just a company working with that. If you can have a free version of the database, you don't even have to worry about that. That's kind of nice too. So that licensing cost is a big deal. Audits is the other one. There are a lot of companies that are looking to audit people who are already using these products. Oracle is well known for this. SQL Server does this as well. To be able to escape that is just one more risk, one more threat to your technical world that you don't need to worry about. So, as I was saying, there's over 25 flavors of PostgreSQL that are pretty much the known. There's always new ones coming out. People are always coming out with different ones. The horizontal scalability and vertical scalability, that just means we're getting a bigger machine. Horizontal scalability, that means that we're able to scale out with more replicas. If we're looking at replication there, if we're looking at sharding, we're able to spread the workload across more nodes, more servers, and be able to get better performance there. Multi-model support, serverless, which is a big deal, especially when we're starting to talk about the way that we want to be more agile and that we don't want to be kind of that client-server environment, which is very archaic. A lot of people are trying to get away from that. Time series as well as JSON native capabilities. How many people here are working with JSON data at all? How many people like it? There we go. Yeah. I like to always check on that because I know how I feel about it. Postgres, it's not the little RDBMS of the 2000s. I mean, like I said, I worked on Ingres. I had a customer that had Ingres, their manufacturing systems, and I had to manage it. And I really was feeling pretty good about being the only female DBA, and I didn't have to be the only one vacuuming databases. But, it's just that challenge of saying that these are these systems that have really come up and kind of matured. where it was just this simple database that people were using for an open source product that they were hoping that they could get along, and hopefully the code wasn't going to go dead, and they were setting on a system that was without any code base that they could support. It's now something that is supported and loved through everybody's realm. There are 150 major releases added over the last 5 releases. This is major releases, including the long-term support for Postgres for 5+ years. This is also crucial. As much as we know we need to patch and we need to upgrade, knowing that your version is going to be supported long-term is a huge relief. I deal with this every single day. I watch companies deal with this as they try to get people to upgrade, and at the same time, you're kind of sitting there going, if it ain't broke, do I really need to fix it? So it's definitely beneficial knowing that you're going to be supported long-term. Global contributors to this is huge. It's not a single vendor product. Having companies decide what is in your best interest when they may not be working directly, those decision makers, with what you need can be really challenging. And I find when communities are the ones that are kind of pushing the development, not just organizations, it makes a huge difference in the quality of the product. There are 700 plus contributors to Postgres. My company has been one of those. I was really impressed with my coworker Ryan Booz, that he put so many investments into this and so many recommendations and changes into it. Microsoft has AWS, EDB, of course, enterprise databases everywhere, Fujitsu, Crunchy Data. These are all folks that have put in their time and effort to make this product better. The active mailing lists, I get the newsletters every single week. I learned so much from those. I really, really appreciate those. The active mailing lists are constant, that you see people that are using this product every single day, that you can learn from them, that you can help other people. I think that really is a big deal. It may seem archaic in some sense. I mean, we still use mailing lists for Oracle too, so it doesn't surprise me. But it's very helpful to be able to talk to other people and network with other people who are actively using it. And this global development group, yes, it is a guiding force, but it's not so controlling. It's mostly trying to help people to guide them in the right direction with the product. Postgres is the default RDBMS for Kubernetes. And Kubernetes means that it's going to make us more flexible, that it's easier to utilize, that we can deploy faster. This goes for Crunchy Postgres operator as well as the Cloud Native PG operator. Those are all available. It's integrated with GitOps, Helm charts, cloud backups, and of course serverless Postgres with Neon, Supabase, Avian, Neon Tech, and Nile does this as well. So the technical details on this, it is full ACID compliance. That's atomic. I'm going to get stuck on that word again. Atomicity. Can't say it. Consistency, isolation, and durability for ACID, if you're wondering what that if you're new to it and don't know what it stands for. It's how you ensure your data reliability. Supports complex queries, window functions, CTEs, JSON, JSONB, arrays, etc. That's, pretty much essential for any relational database, but it is at that point. As much as it conforms closely with SQL standards, which makes migration, especially with the foreign data wrappers, make sure, I'm going to make this clear again, from commercial RDBMS platforms, more predictable, those migrations. Again, I'm not seeing as many robust enterprise level databases migrating successfully. Many times what happens is that they will say, we are going to migrate off of SQL Server, Oracle, we're going to go to Postgres. And these projects will migrate the database very quickly, the objects, just the main objects, indexes, all of that, very quickly. Maybe a week, maybe 2 weeks. And then the projects sit for a year, 2 years, up to 4 years trying to migrate over the procedures and the code. They may count their chickens before they're hatched. That's where most of these failures come in. And I do want to kind of stress that if your company comes back and saying, we were hoping we could get rid of all of our Oracle or our SQL Server databases and put them on Postgres, and it doesn't happen, this is where the failures usually happen. It's on the internal code, and especially if they're dependent upon very deep deeply architected Windows functions, or they're relying heavily in Oracle on the PL/SQL functions, PL/SQL packages that are built into Oracle. That's where they usually fail. When I was at Microsoft, I used to get 300 failed migrations a year. So that's how many, it was less than 1% actually were migrating over from Oracle to Postgres. So I do want to stress that and why I highlighted that in yellow. But it is all about they who gets the data wins. So one of these things that's really powerful is the ability to bring in JSON data, that unstructured data. Everybody wants to not just have the relational data, they're bringing the JSON into the relational system as well, but they may have a lot of unstructured data that they want to bring in with it. This gives you that ability to do that you can absolutely query it. And I'm going to do a quick demo here in a little bit to show you how easily I can do that. You can bring in the performance data as well. It's maturing. We got to give a lot of thanks to like Kyle Haley and Kevin Clausen and that from the Oracle world that knew that we had this deep performance data that was in the Oracle space around automatic workload repository, and they've tried to build it out. If you look at AWS and look at any of the flavors of Postgres and the visualizations, that's all Kyle Haley. He did it for Oracle Enterprise Manager. He did it for DB Artisan, SentryOne, all of these tools. And what's important about that is that you can actually see explain plans, that you can go in there and see your weight events. They're called weight types from PG stats, your PG activity, all of that, PG stat activity, that you can query that and actually see that data. Being able to see a stacked graph of weights and understand how one weight, let's say in your CPU and memory and all of that, is weighting on another weight event and how they may correspond to each other, I think is really, really powerful. And they've done a good job of trying to start to build that in. We're starting to graph that out even in our monitoring tool of understanding how that is valuable when you're troubleshooting a problem. They've added in high availability and disaster recovery. You may hear from Oracle people that if you're not doing real application clusters rack, you're not doing full high availability. I will tell you that I do not agree with that. Rack is not high availability. It is instance resiliency, and it is there for scalability. So anybody who says that it's HA, a rack cluster, multiple nodes, it can only be in one single data center, which means that it fails HA 101. You can't scale that other nodes into another data center. And especially with clouds, it's extremely important to be able to put your data in another data center somewhere else when that data center goes down. You can do that this way. Being able to have replicas, a primary and a secondary in another replica that's out in another data center, that's really powerful to have that capability. Logical replication, of course, all of these, when you make these choices, depends on what we call our RPO and our RTO, which is our recovery time objective and our recovery point objective. We're going to look at those and say, what do they need for this database environment, for this application to actually meet those SLAs? And if we meet those, what are we going to pick for our architecture design that makes sense? Well, you're going to find all those different flavors. So you may use this one for that application, and this logical replication is enough for this other application. That's all it needs for your database. So I'm going to do this choice here, but I'm going to have to scale out, maybe do sharding and all this other stuff. And that's where you kind of come into these ones. I may be just doing some development databases, and I want to be able to create an environment very, very quickly, delve that out to my developers, and go on and so forth and so on. I may be in the cloud, and I want to make sure that I have recovery and response or multi-region deployments, all of these different things. You will have those flavors that you need depending on what you have. You just need to look at what's available in that cloud or in that environment or in that architecture and build it. So it's pretty cool that you can make all those choices and get there. Then we get into backup and recovery options. SQL dump is pretty much the go-to. It's always been there. It's the original. You've got a lot of people who are using PG base backup and using, I think I'm going to go on the next one here, continuous archiving, point-in-time recovery. This is pretty much, you just need the storage They'll hold on to the archiving and the wall files, and you're just going to continue. And if you need to recover, you're going to bring back that recovery data and just continue to bring it back up from the actual archive or wall files, as we call it. PG Backrest is probably the most popular third-party tool that I've been seeing people use for their backups. It's easy to configure. I think it's easier, I should say. And it's a high-performance one. So if you've got a bigger database, it really comes in handy. And then we get into extensibility and customization. We talk about our ability to do complex indexing types, no matter if we talk about GIST and GIN and SPGIST and BRIN. When we start indexing, we're trying to vertically break down our data when we start to get to those rows and find a way that we keep from hotspots and we get to that data very quickly. So we may reverse key our actual data. So we're looking at it, we're reading it a different way. Then we're going down through the rows. We may look at it so that we want to bring in that data for JSON and be able to do similarity searches. All of this stuff is capable within there. You have procedural languages and foreign data wrappers. We were talking about these. So for PL SQL, we've got one for that inside Postgres. If you've got something, DB2, of course, takes advantage of that too, as well as other database platforms, T-SQL for SQL Server, that's that we can actually do those kind of translations, makes it multilingual. We can write our own extensions. So if we need certain capabilities built into there, that's one of the nice things about open source is that we have the ability to build what we need. Some of the extensions include like the PostgIS for spatial data. So you have that capability to do the X and Y's and actually compare that out and build out your actual spatial data. PG Partman for our partitioning, when we start getting into larger databases, and we need to be able to parse through that data quickly, where indexing is kind of vertical, partitioning is going to be horizontal slices of those tables that we can actually do what we call hashes and create our own tables within memory and get to that data quickly versus having to go through it vertically row by row. And PG stat statements allows us to get into that performance tuning. So we can actually look at our statements, get explain plans, find out where performance may have gone wrong, and improve that, hopefully, with optimization. And then we start looking at some of the lock-in. This was an interesting one to me, that when I went in and decided to move my blog about 2 months ago, found out I didn't have to use a MySQL database. That was always the default. I can use Postgres now. That's a capability, but this is also huge. Everyone I know that's come across this has moved to a Postgres database. This has got to be a huge hit on MySQL. No question about it, because I know how many blogs with WordPress use MySQL behind it. And it doesn't change the PHP admin basis that is still there, but it's pretty impressive that they're now using Postgres as well. And it's got rich data type support. So as we were talking about UUIDs, JSON's the big deal, XML, again, anybody like XML too? Yeah. Full text search and geospatial types. And then the flexibility to use all of these cases, including document stores, key values, relational data, all in a single engine. Again, this is a big deal that we're able to do all of this, and this is all open source. MVCC, this is another thing that we have. One of the things that fascinates me about Postgres, that in Oracle, as we scale up, I was talking about rack and everything, is that you have a lot of concurrency issues, because you go to put in another block and somebody else is trying to get to that row. You can have these concurrency blocks that are happening in there, and yet here we're going to write a new row and get rid of the old row. And how this makes it highly concurrent, that you're able to get better performance for OLTP workloads. You do have to clean up those old tuples later on, but it's pretty impressive how it writes and addresses some of these concurrency issues that we just don't have the answers to in some of the older relational systems. Parallelism and performance optimizations, yes, we can do parallel. You can go in here and say, I want to get higher performance. I'm going to put multiple processing to get to all of these rows. Let's say I've got to do 1.2 trillion rows. It needs to come back in this query. And I'm going to break it up into multiple processes and let all of them grab this data and bring it back faster and knit it back together. The indexing strategies we talked about across various data models, depending on what you need, you have different index types that can help perform better. the security and role management that's in here, where you have fine-grained control. One of the things that I've been seeing, and the reason that I think that it's really essential that Postgres is being brought into some of these other platforms, no matter if it's Snowflake, Databricks, Fabric, is that relational systems have that advanced security that may not be in flat file systems. I can't get over how frustrating it was for me when I found out that it was only supported to protect the Fabric data for the, they've got Parquet files sitting out in storage, that it was really only Windows-based protection on the file folders like you would see in your PC. That freaked me out as a database administrator. I want to have multi-tier protected layers on my data. And that having this here, a relational system, means that you're going to have that protective mode. And so I'm really thrilled when I see this built into Fabric now, that they're going to have that to give us advanced areas of protection, because our data is pretty much under attack these days. Anybody who goes in and watches like TLDR with their, download either their data or their InfoSec newsletters, you're going to see those breaches every single day, and a lot of them are into actual data from, no matter if it's AI, no matter if it's flat file systems, all of this. Hacking is a big deal right now, and if we can find ways to protect it, make it as difficult as possible for anybody to get into, I'm for it. So the more of PostgreSQL, cloud native and ecosystem friendly. The cloud vendors like AWS and Azure and GCP, they've embraced it. It's open source licensing, it's multi-tenant ready, broad compatibility with modern analytics and AI platforms. They've all built it into their analytic systems. I think that's really essential as we're going forward. We talked about the foreign data wrappers a little bit, but Oracle, SQL Server, MongoDB, CSV files, REST API, we're bringing more and more data into an open source arena so that we don't have that lock-in at the vendor layer. Now, again, I talked about the limitations on some of these, but it doesn't mean you can't feed the data in. I think the challenges are when we try to migrate from those big, monstrous, robust, archaic systems. The vibrant community and innovation, I think, is a huge deal. The contributions, they're driven with real-world use cases. And the ideas stem from many large-scale deployments, and that's one of the things that we're seeing, is that they're for the reasons. When we start talking about Instagram with Meta and Postgres, they have brought it in and started to actually manage all of their systems that go in and search for images. These are all set for this. They were able to do this with low latency. They were able to do it in scale, as well as the redundancy that they needed to protect all of that data. Red Hat is using it for their internal systems as well as analytics. GitLab brought it in for the open source reliable features. It's just a rich database for them. They brought it in for extensions and custom needs, and they built a lot of those out too. You'll see them out there, that they're the ones who had designed them out. PG Bouncer for HA and connection pooling. They're doing a lot of sharding and partitioning with their data because their databases are quite large. They did find that it was very successful for them, and they're using it for tens of millions of projects every day. NASA's using it for the telemetry and the research data systems right now. And then this is the one that I was part of that I really enjoyed. I threw this one in because I just love this project. That we are using BigQuery as well as AlloyDB. And what's going on is that it's using these, the best way of describing it as facial recognition software. That it is taking pictures of the lions and it is identifying them by their faces, and then using the lineage and keeping all of this data clear, and also because it's tracking where they're at with all the cameras that are available there, that they can know where they're at, keep human interaction down to a minimum, watch for any kind of health issues, look also for poachers, and do all of this and track all of this in real time. So very, very cool project. I had fun on that one. And here's kind of the comparisons between these. That even though these are the relational systems, and I will say this very clearly, I feel like I should have compared these to some of the other open source databases that are out there. And I definitely didn't put MongoDB here because I always see people kind of comparing Postgres to MongoDB. And MongoDB to me it's a document database. I almost want to say, if you were comparing it in layman's terms, saying that you have Word and you can put an Excel spreadsheet in it, embed that in there. So why do I need Excel anymore? It just doesn't make sense, the comparisons a lot of times. So for me, I just want to say you need all the tools in your tool belt. So definitely have reasons for MongoDB, but I don't know if it fits in that graph. So demo time. This is just going to be a real quick demo. I am going to do JSONB, GIN indexing, install an extension, do a couple modern indexing, verifying a comparison. Bring this down. See what we got here. I just created this database, so it is empty, empty, empty. Go to my scripts here so you guys can see what I'm doing. Oh, look at that. It's not sharing that. You can't see what I'm doing. I need to duplicate. Maybe. Do what I said. Give me a second here. I know. Duplicate these displays. Thank you. Oh, that looks so much better. Can you read that in the back? Yeah. Okay. Created a database real quick. I think I'm already over there too. Let me double check. Oh, it's so helpful, let me tell you.
Is that Visual Studio?
It is. So I just created a database, went and added in a schema and switched over to it. I am going to do this now. I'm going to create a table called products, insert some data into it, and then create an index on it. And this is with JSON. So let me, if I can find any of my windows this week. And if I can type. Once I get this in once, we're in business. Let's do it. That's what I want. Because I hate typing. There we go. So we created our table, we inserted 2 rows, and then we created our indexes. And then our next one, we're going to query our JSON. There you go. And that is just querying through the JSON. We were able to bring back and pull that laptop information from that full JSON information. So we can do JSON, we know that. And let me bring that up too so you can see that, what I did. There it is. Just select product data, name as product, from products, where product data, and there you go, there's that JSON query. And then we're going to create a similarity search. And I want to bring that up so you can see that too. this one here, we're going to create an extension first. So there's my extension, my PG term. And then I'm going to create my similarity search. And it's going to grab that too, along with my index based off of it. So I'm going to install the extension, create my table, insert the data, and then I'm going to do a similarity search on that. Again, if I can type. There we go. Did all of that. And then we're going to query it to show how that works. And I'm going to be lazy and I'm just going to copy it. And there it did the similarity search between these, showing the differences between it, how similar it is by the names. Does that make sense, how it showed the difference in the names and how similar they are? And then if we look at this, just so you can see this is new. Demo 2. Well, I can use this one, I think. Refresh. Yes. We're going to, what this is telling us is that we created all of those objects. This is confirming and letting you know. All of those objects I showed you, I went and created in both the databases. So it tells you now that these databases are similar. I just used PG compare to verify that all the stuff I just told you I created in that new data, in that new database, I created. But you can see how easy it is just to create something. Whatever I need to do, it is right there. Now let's change our settings back. And bring back up current slide. And we're back. So what can you do today with Postgres? OLTP, OLAP. So it doesn't matter if you're doing transactional, analytics, it's all available there. Time series, it's available to it too with Timescale DB. Federated systems, and federated means that you are taking the data from that other system, no matter if it's Oracle or SQL Server or whatever, and bringing it into Oracle. Event-driven data and JSON-based document stores. You can strategically monitor it. This is some of the data that I'm pulling in with like Redgate Monitor, and I can see the peaks, I can see the averages, I can see performance over long term. All of that is available within there. It is in its infancy. It's getting better every day. And again, that's probably coming from somebody like myself that comes from the Oracle world that's used to pretty advanced performance data. But for a lot of other folks, it's pretty impressive. I mean, it is getting there. That we have full explain plans, that we can find out what's going on, how things have changed, and how we can enhance performance and find the best plan or the most optimal plan that we want to use in our actual travels through the database to get to something. And missing performance data, yeah, there is no canned reports, and that's AWR's automatic workload repository, the active session history, and the automatic database diagnostic monitor. Those are all Oracle features. But significant data is still there at the host level you have to grab as part of Postgres because it is very integrated with its OS. There's no session level information like Oracle's Ash data or SQL Server's DM exact weight stats. It requires third-party tools to monitor the historical data, yes, but they're out there. They're absolutely out there. The one that I was just showing you, the PG Now and PG Compare, I can do it with that and keep on to historical data and grab baselines, everything. Limited query execution information, it requires PG Store, that the actual store plans, you have to keep that. But again, that's just an extension. Install it, configure it, you're ready to go. And very little to no I/O latency breakdown, but you can collect the information on I/O. PostgreSQL can be CPU heavy on complex queries. There are ways to optimize that, of course. And vacuuming tuning still requires platform expertise. Default vacuuming settings or the auto vacuum probably isn't for the best. You probably want to rethink that. Not all features are plug and play. Partitions and that, you have to do that work yourself, and sometimes you have to script that, absolutely. So it's worth it. And scale out requires third-party extensions like Citus as well as Gigabyte. So why is it still winning? There's no license cost. Rich features, community-driven. It's suitable for a lot of cloud environments. There's always a flavor that's available out there no matter where you're going. It's very fast on the innovation cycle. I mean, versus traditional enterprise RDBMSs, I mean, you're not waiting for any enterprise company to come out with this. And it has support for all the major hyperscalers. You don't have to worry too much about even the enterprise companies not delivering something. And if you want to learn more, start a test project. It's pretty easy to do. Superbase, they've got some pretty easy ones. Crunchy Data, Azure DB's Postgres in Microsoft Learning. They've got a whole bunch of projects that you can start on. And you can use Google AlloyDB anywhere. They're always about people doing it. And I also have a ton of links here, if you're interested in it, where the Postgres downloads are, Superbase, AlloyDB Omni, GitHub projects, 1,000 PostgreSQL projects here. You can all test them out, along with the free tools that are available for doing comparisons and doing like looking at performance and everything in your top SQL and all that. And with that, I have my cute little dinosaur here if you want to follow me or have any information or want to contact me and ask me any questions. And with that, I am at Q&A. I've like bludgeoned you with all kinds of information for the last hour. Any questions? No? You guys like, let me go. Thank you.
You got a question?
Sorry.
Please.
I thought we were going to clap and then do questions.
Yeah.
I don't know if you know very much about, like, I guess organizationally how Postgres works, but like, what do you think has made them successful in terms of like getting the technicals? I mean, just why do people contribute their time to Postgres when other open source projects?
That's interesting.
I feel like that's something that they struggle with.
I'm going to say this from the Oracle perspective. What was really intriguing with them is that, especially the Oracle scientists, the Okies, we like to fiddle. We like to figure things out. And Oracle was pretty much figured out. It gave them some place to work and really be valuable and contribute, which they hadn't felt in a long time. I was watching that and I was very fascinated by it. So they were happy to. They loved contributing to it. For the other communities, you know, it'd be interesting finding out. I'm looking at you, you know it, right? Yeah, sorry, Mark. Do you know from the MySQL side what is intriguing about like the Postgres group? Anything? Really?
I mean, now the big issue, well, I don't know. If we turn the camera on.
I don't want anybody to hear this. Wait.
Well, I would just say, I think that the leadership, vision, and direction of what was the MySQL community, you know, a decade plus ago, isn't there anymore. And so the people in charge of it now, I think that leadership and direction is different, I guess I'll just say, and maybe
It's
not
just different.
coordinated. So, and I think they look at Postgres as like, if you were originally there because you liked open source and you like to be able to get access to people and have community around that, what's the nearest thing, right? And it's Postgres is kind of the obvious stuff, I think.
That makes sense. Yeah.
Is Postgres really organized, or is it very like self-governed, or?
It's really disorganized.
Oh, do we need to really shut that camera off because I know this? Yeah.
I guess I would say Postgres, almost everything in Postgres is the simplest way I would put it.
But I would say from the Oracle folks, that was really what it was about, is that Oracle had gone all in on OCI, which, I mean, they have every right to, absolutely. And it was fascinating for most of the Oracle scientists to really dig in and be able to contribute again. Most of us got in trouble when we were at like Oracle Open World. We did start out with Oracle Closed World, which we got in trouble with and got a cease and desist letter on that. And then we did Oak Table World. And we got to talk about what interested us, what project we were working on that was fascinating to us. And so people would just show up and we'd do this project or this conference free right next door to Oracle Cloud World. So it was something that we did. But you knew that, you saw everybody that was there, they wanted to fill in, they wanted to work with technology, not just be driven by what was a service. And I think that's one of the big challenges, is that many times the cloud is a black box and you may not have fascinating technical challenges to work on. And I think Postgres definitely gives us that opportunity. You know, I found that. I'd see people like put up challenges on the Postgres newsletter or on the mailing list. And I'm like, you gotta look at your log. They told you to look at the log error. Like, let's just troubleshoot this. This is troubleshooting 101. And you realize there was a lot to contribute. There was a lot to give back that maybe we didn't have in Oracle anymore. So that's just kind of my feeling on it. And I think that's why people contribute, is you want to be needed and be able to contribute and be productive. And that gave us that opportunity.
That's beautiful.
Did that answer? Okay.
Yeah.
Any other questions? You're all free to go. Enjoy the rest of your day. Thank you.